Hello students, in this week's video, I'm going to teach you how to solve trigonometric equations. The questions are from exercise 11.2. If you're having problems managing finding angles, negative angles, where the range given is in the negative angles range, do watch this video because I'll be doing a few questions on that. Right, let's look at some of the concepts that are needed so that we can solve trigonometric equations effectively. Let's start off by having the Cartesian plane. Yes, and if you were to recall that alpha is the reference angle or the basic angle, which is a very important angle that we need to find because all other angles are actually based on this reference angle, right? And reference angle is actually a acute angle. It's an angle that's more than 0 degrees, less than 90 degrees. All right, so there are two types of angles that we have to manage. One is called the positive angle, where the directions is in the anti-clockwise direction. Right, so in this case here, what we are saying is that you start off with 0 degrees here, then followed by 90, excuse me, followed by 180, 270, and then you go back to 360. Right, so if you're to remember your ASTC, what it means that in the first quadrant that's between 0 to 90 degrees, or all the trigonometric ratios, the values of all the trigonometric ratios will be a positive value. In the second quadrant, only the sine ratio is a positive. Third quadrant, tangent ratio is a positive, and at the fourth quadrant, cosine ratio is a positive. Right, so supposing if you're asked to find the angle from the first quadrant, then the angle theta will be just be alpha itself. Yes, we're only considered one full circle. All right, one full circle. That means comprises only the four quadrants. So if the angles is found in the second quadrant, then the angle theta will be 180 minus the reference angle. And if it's in the third quadrant, it will be 180 plus alpha. And fourth quadrant will be 360 minus alpha. All right, so what happens if you're dealing with a negative angle? So for negative angle, then you have to measure in a clockwise direction. All right, so it means that you will start off with 0 degree here. That is negative 90. That is negative 180, negative 270, and then you go back to negative 360. All right. All right. So the ASTC remains the same. All right. That means in the positive angle, the first quadrants, in the first quadrants, all your trigonometric ratios will be positive. In the negative angle, right, because your angle is measured in a clockwise direction, so the first quadrants become the fourth quadrants, right? So the fourth quadrants is the quadrants that where all the trigonometric ratios will be positive. Okay, and then your second quadrants in the positive angle will become the third quadrants of your negative angle. Okay, so on and so forth. So supposing if you want to find if the angle that you're interested to find is in the first quadrants of a negative angle, then the angle theta will just be negative alpha. Right, and if it's in the second quadrant, then it will be just negative bracket 180 degrees minus alpha. If it's in the third quadrant, it will be negative bracket 180 plus alpha. Fourth quadrant will be bracket negative 360 minus alpha. All right, so the just to summarize, so for the positive angle, the first quadrant will go in a anti-clockwise directions. Right, in the negative angle, it will go in a clockwise directions. Okay. However, the trigonometric ratios, right, you will see that the quadrants, right, remain the same. If you look at both the positive and negative angle, right, the quadrants, this one, it tallies with this one here. It's the quadrants that where all the trigo ratios are positive. And if you look at the this quadrant here, right, which tally with this one here, that is the quadrants where only your sign ratio is positive. Okay, and then this quadrants here, which tally with this one here, is where your tangent ratio is positive. And then finally, this one here, with this, it is the quadrants where your cosine ratio is positive. So I think it's if you find it confusing, right, you just remember that ASTC is the same for both the positive and negative angle, where the position, okay, we're not talking about the quadrants, the position, your ASTC is the same for both the positive and negative angle. However, for a positive angle, you have to measure it in a anti-clockwise direction. So your first, second, third, fourth quadrants will be different from your first, third, second, fourth quadrants of a negative angle. All right, so let's look at the first question 1C. If you look at what I have given to you on the right hand side, I've given to you a few questions there, right? So I'm just going to show you how we can do question 1C, and then you can just try to do 1A, B, the other questions all on your own. And I've also provided you with the answer key. So these are the answer key. All right, so let's look at how we can do 1C. All right, so under your ASTC, remember that if your trigo ratio is a negative value, right now it's negative, right? It's negative 1 over square root 2. Then the only two quadrants that will gives you trigo ratio or negative values will be from the second and the third quadrants. Right, so it would be good that you can just remind yourself that the answer that you are getting, the answer for X that you're getting from will be from your second or the third quadrant. Okay, and of course, yes, we have to find alpha. And since alpha is actually a positive, it's a acute angle. It's an angle that's more than 0 and less than 90. It's a positive, it's a acute angle, sorry. Therefore, you see that when I cosine inverse it, I must cosine inverse a positive value. This one here must be a positive value, so that I can get an acute angle for alpha. 1 over square root 2, if you recall, is actually cosine x equals to 1 over square root 2. It's actually a special value, right? So when you cosine inverse 1 over square root 2, the calculator will give you 45 degrees. However, because the range given to you is in terms of pi, that is in radian, therefore you have to convert your 45 degrees to radian. That is 45 over 180 times pi. That is 1/4 pi. That means pi is 180. All right, pi is 180. Okay, so 180 divided by 4 will give you 45. So therefore 45 is 1/4 pi. All right, it's quite easy. You just take the angle divided by 180 times pi. That will help you to convert an angle in degree to radian. Okay, so now the next important thing is that, oh yes, I've already explained to you earlier on, okay, that it's important to know where you're getting your angle first from. There are two things is very important here that you remember. First is to find alpha, but alpha is always an acute angle. So therefore, when you cosine inverse, sine inverse, tangent inverse, any value, the value must be positive, right? Then the next thing is that to recognize where your answer must come from. And to recognize where your answer must come from, will always go back to your original questions. Here we're having a negative value. So the negative value means that the value of a cosine functions of a negative value will only come from a second or third quadrants. And if you recall the concepts that we learned earlier on, second quadrant means 180 minus alpha. So 180 is pi, so pi minus 1/4 alpha. So that gives you the answer from the second quadrant. And the third quadrant will be 180 plus alpha, which is pi plus 1/4 pi. Okay, so this question is relatively easy. So you can go on and try to do B, C, D, E on your own, and then you can just check the answer given. Okay, so oh yeah, I actually did 1D as well. Right, so let's look at how we can do 1D. Tangent square x equals to 4. Now some of you, sometimes when you learn new things, right, somehow you actually forget about all the past knowledge that you have, right? But you will see that whatever past knowledge you have about solving algebra equation, algebraic equation, algebraic fractions or whatever, still holds when you are managing trigo, right? For example, if I'm going to replace a tangent x with the letter y, if I'm just going to let tangent x equals to y, then tangent square x is tangent x times tangent x, so that gives you y squared equals to 4. So remember how we actually manage y squared equals to 4? If you want to find y, then I can square root 4, right? I would be able to get two values, positive 2 or negative 2. Right, remember that? So the concepts that you have previously still holds here. So therefore, your tangent x is positive or negative 2. And like what we have mentioned just now, we need to identify the quadrants where our angle x will come from. So in this case here, the value is positive or negative means that it can come, if it's positive value means it can come from the first and the third, right? If it's a negative value, it's second and fourth. So basically, we're talking about this angle x that can appear in all the four quadrants. Okay, so we settled that already. Then the next thing is to find alpha. So alpha is in the cube angle, so I must tangent inverse a positive value. So I must tangent inverse 2. Okay, and here also comes the tricky part because the answer has to be expressed in the radian mode. This is radian mode. Between 0 and 2 pi is radian mode. So you have to use a calculator to change the mode to the radian mode. Okay, so you have to change the mode to radian and then press tangent inverse 2. That will give you 1.1071. Right. So the first quadrant will just be alpha itself, expressed to 3 significant figure, because right now we're talking about an angle that is expressed in radian mode. So it should be expressed to 3 significant figure. So first quadrant is 1.11. Second quadrant is pi minus 1.11. Third quadrant is pi plus 1.11, and 1.1071. You need to have more decimal places so that your final answer will be more accurate. And then the fourth one will be 2 pi minus 1.1071. It gives you 5.18. All right. Right, let's look at the next question. That's from 2C. Right, secant x negative 1 equals to negative 3. Now, so you have to do consistent practice so that you can remember what you have learned previously. Right, because a lot of times in this chapter on trigonometry, we have to use all the concepts we've been learning throughout. The new one will need you to apply what you have learned previously. So like for example, secant x you have to recall is 1 over cos x. So if you do not remember that secant x is 1 over cos x, then you are kind of like stuck, don't know how to go on. Right, so we just flip it on both sides so that get cos x equals to negative half. All right, and so for cosine ratios to be a negative value, the angle will come from the second or the fourth quadrant. Okay, then the next thing is that, can you see it's kind of, it's a method, so it's quite standardized or quite systematic. So the next thing is to find alpha, and alpha is in the cube angle, so we need to we need to cosine inverse a positive value. So we need to cosine inverse half, which gives you 60 degrees. Always go back to the range given. The range is between 0 to 360 degrees. That means your angle is in degree. So that's fine. 60 degrees, don't need to convert to radian. All right, so let's look at how we get the answer from the second quadrant, which will be 180 minus 60. And from the third quadrant will be 180 plus 60. Right, so that's how we get to both answers correct. You can check the answer here. These are all the answers key. Okay, and you may want to try other questions as well on your own, and the answers are provided there for you to check. Alright, so here we are. Question 3 involve us to find angles from both the positive side, not the positive side, but the positive directions, and also from the negative directions. Okay, so let's look at the questions first. That is tangent bracket x minus 0.1 gives you negative cos pi. You can easily use a calculator to evaluate cos pi, but if you were to remember the shape of your curve, the cosine curve y equals to cos x, you would remember that cosine 180 or cosine pi gives you negative 1. So negative times negative 1 gives you 1. So let's identify where we should be getting our answer from, because you get it's a positive value, 1 is a positive value, so the answer would be from the first and the third quadrants. Alright, so first thing first is to find the alpha, which is just tangent inverse 1. You can just use a calculator again. Tangent inverse 1 gives you 45 degrees, but we need to convert 45 to radian because the answer given is between negative pi to 2 pi. In this case here, is actually what do you call it, special angle, right? You can actually express it exactly in terms of pi, right? Which is 1/4 pi. There are some answers that you cannot put it in terms of pi. Like for example, tangent inverse 2, right? It's 63.43498 blah 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 is an irrational number, so there's no way that you can actually uh, express it exactly in terms of pi. However, like this 45 degrees, right, is an exact value. Exact value you can, because you just take the exact value, divide by 180 to give you a rational number, and then don't times leave it in terms of pi. This is what it means. Leave it in terms of pi. Okay, so it's 1/4 pi. All right, you don't use a calculator and then take 1/4 times. The calculator pi don't do that. You just leave it in terms of pi. This is what it means. Okay, so for the first quadrant, so we need to find the new range, because if we were to look at questions, we are not finding x. We are finding x minus 0.1 first. Okay, ultimately we have to find the values for x, but we need to look at x minus 0.1 first. So the new range will be, oh okay, wait, so we need to talk about the range. Yes, the range is between negative pi to 2 pi. So if you were to break it up using a number line, it means that you need to get the answer from negative pi, from 0 to negative pi, which is the negative angle directions, and then from 0 to 2 pi, which is the positive angle directions. Okay, right, so let's look at the positive one first. So far we've been dealing with positive, and it's more manageable than the negative one. So let's look at the new range. So the new range, basically you just minus, subtract 0.1 throughout. So 0 minus 0.1, 0 minus 0.1 gives you negative 0.1, is x minus 0.1 will give you x minus 0.1. 2 times pi, just calculator, pi is 3.142 blah blah blah, times 2 minus 0.1 will give you 6.183. Alright, so let's go and find the first angle, which is from the first quadrant. Basically that will be just alpha itself. Okay, and then you can find x. Right here, then you have to evaluate. There's no choice, you have to evaluate already. Right, you can't just leave your answer as 1/4 pi plus 0.1. Okay, here you need to use your calculator. Take 1/4 times 3.142, then plus 0.1 to get 0.885. Express the three significant figures because your answer is in terms of radian. Only when it's degree, then the final answer is one decimal place. Okay, let's look at what happened in the third quadrant. So for the third quadrant, it's basically just alpha plus 180 or alpha plus pi. And that will give you 4.03. Okay, so we settle the answers on the positive angle range. So now let's look at the negative one. Okay, negative angle is between negative pi to 0. So if you look at your negative angle, right, your ASTC remain the same. Okay, the ASTC does not change. Okay, whether is it for the positive angle or for the negative angle. However, if you're talking about negative angle, then the quadrants will no longer be the same, right? For negative angle, then this will become the first already. This will be the second. This will be the third, and this will be the fourth. Okay, so it's a bit tricky here. Okay, if you the ASTC remain the same. So in other words, since we're dealing with a positive value, your here this is positive, right? Positive means your answer will come from the first and the third quadrants. The first and the third quadrants refer to your positive angle, the positive angle quadrants. So the positive angles first and third will tally with your fourth. It will be here, and the third will be here. Okay. Take a while to understand it. All right. So in this case here, the fourth quadrant is actually the fourth quadrant for the negative range. So to find that, you would have to take bracket negative 2 pi minus your alpha, right? But if you look at the range is actually between, you see, it only comprises of your first and second range. Can you see it's between negative pi to 0? So it's only, you need to consider for first and second only. So you don't have to worry about the fourth one. So you don't have to worry about fourth one. So the second one, how to find the second one? The second one is basically just negative bracket pi minus alpha. Yeah, this is what I've explained just now. Okay, in case if you don't quite understand, you just do it lah. Just do it and then reject lor. Okay, and then yeah, the second quadrants will be, okay, negative bracket pi minus 1/4 pi, and then you can just use your calculator to evaluate to get negative 2.26. All right, if you don't quite get it, please look through again. Basically, it's a bit it's a method for solving trigonometric equations, so you just have to like remember the steps. Okay, let's look at another questions. 3A is slightly more challenging than 3B because you not just need to worry about finding angle from the negative directions. You still have to worry about 3x. If you look at the questions, you're given cosine 3x. Basically, all the time you're just solving like tangent bracket, like x minus 0.1 or sine x, the kind of thing. But suddenly there's a cos 3x there. So what does it mean? Okay, so the first step is to identify for the positive angle. The quadrants will be from the first and the fourth quadrants. And we find alpha, all right, which is cosine inverse 0.560 degree. You can again change it to radian mode. It's actually a special angle 60 degree. So it's just pi over 3, and then let's find the answer for the positive angle first. Okay, but before that, wait. You need to find x to be between 0 and 2 pi. But since we're finding 3x, there will be a new range. You need to find a new range. Right, so it just times 3 throughout. Okay, so the new range is, that means your answer don't just come from between 0 to 2 pi. It will have to go another one more round, which is between 0 and 4 pi, and then another one more round, which is between 0 and 6 pi. This is what it means. 0 to 2 pi is just like one round. Okay, you start from here, you go one round, that is 0 to 2 pi, right? So if you go again another round, that means it's 0 to 4 pi, right? Because 2 pi plus 2 pi is 4 pi. Then if you go another round, means it's 2 pi plus 2 pi plus 2 pi, 6 pi. This is what it means. Okay. All right, so 3x, let's find the answer for the first quadrant first. Basically, just your alpha. Then the fourth quadrant will be 2 pi minus alpha. Oh, sorry. Okay. What I've done here is that I categorize the answer such that we settle everything in the first quadrant. So first quadrant, first answer is, if you go one round only, it's, oh no, sorry, yeah, go one round is pi over 3. This is when you go another round. You need to go another round is because, like what I've explained just now to you, the new range for 3x is you need to go 3 rounds. Okay, so one round is just pi over 3, right? And then you go another round, which is you need to add 2 pi to your pi over 3. and you need to go another one more round, which is you add 4 pi to your pi over 3. Okay, then from there you find your x. Alright, so this is the answer for the first quadrant. Okay, let's look at the answer now for the fourth quadrant. So for the fourth quadrant will be 2 pi minus pi over 3. That is one round, right? Second round will be add 2 pi to the original answer, and then one more round, 4 pi to the original answer, and then finally use your calculator to get the final answer. So you see that we actually have 6 answers there. If it's just one round, it's basically 2 answers, right? 2 rounds will be 4, 3 rounds will be, you need 6 answers. Okay, so that's for the positive angle. So in the next slide, we'll look at how we manage the negative angle one. Right, so what we have found in the earlier slide is alpha, which is pi over 3. So now let's look at the negative angle. Right, let's start off with our ASTC. Right, so but in this case here, for the negative angle, because it's in the clockwise direction, then your quadrants will no longer be the same as in the positive angle. Right, in this case here, this will be your first quadrant, this will be your second, this will be your third, and this will be your fourth. Alright, but your ASTC remain the same. Okay, the ASTC remain the same. So in other words, what's happening here is that for the negative angle, right, for cosine to be positive, your answer must come from the fourth quadrant of your negative, which correspond to the first of your positive. Then the first of your negative correspond to the fourth of your positive. Okay, but we don't need to confuse yourself with that. That doesn't matter. You just need to remember in negative angle, your ASTC always remain as ASTC like that. You know, whether it's positive, negative. It's just that the way you label your quadrants is different already. Negative angle, then this will become your first, second, third, fourth. Is different from your the way you label your quadrants in your positive angle. That's all you need to remember. Okay, so for alpha to be positive, you come from the first quadrant of a negative angle, which is just negative alpha. So that would be one round, and then the second round is plus 2 pi. The third round is plus 4 pi, right? Okay, and then after that, you just find your x. And you find that the last value is rejected because you'll be out of the range. Later I'll show you. The range is between negative pi to 0. So the last answer will be out of the range. So you can just reject the last answer. This one will be rejected. Okay, let's look at the fourth quadrant. So for the fourth quadrant will be 2 pi minus alpha. And then you need to add 2 pi to go one round. And then add another 2 pi to go a second round, which is 4 pi. Because 2 pi plus 2 pi give you 4 pi. Then finally you get the workout. And then you will see that the last two answers is outside the range. Why is it outside the range? I'm going to show it to you how to find the new range. Right, so you're supposed to find the answer for x will be between negative pi and 0, right? But since we are finding 3x first, you're finding 3x first, so it's between negative 3 pi to 0. Right, so we just, actually you don't have to add this 4 pi. Okay, because this one, if you were to recall from the positive angle that we did, right, this one is you add 4 pi is when your 3x must be between 0 to negative 6 pi, right? But our answer is just up to negative 3 pi only. Okay, but if you find it confusing, like, you know, when to add how much, never mind lah, you just just add 2 pi, add 4 pi, and then finally, in the end, you just reject the answer. If it's just out of the range, then you just reject, and then you just reject. Okay, right. So this is how you solve angle from the in a clockwise direction. Okay, for the next questions, we are given equations in terms of two trigo functions, cos and sine, and basically we can't solve it we can only solve a trigo equations where everything in terms of one trigo functions, either in terms of sine, cos, or tangent. So if you look at this one here, then it gives us an idea that I will have to use your trigo identity. Okay, your three trigo identities you have learned earlier on. One of them is your sine square x plus cos square x equals to 1. So we can use that. All right, and remember your, okay. All right, so what we're going to do now is I'm just going to use some substitutions to make the equations looks familiar to you. I'm going to substitute cosine square x with the letter A. Yeah, then what you get will be 2a squared, because cosine, this one here, basically is just cosine squared x times another cosine square x. Right, that will give you cosine to the power of 4x. So if you replace your cosine square x with a, that will be a times a, and that gives you a squared. So you will end up with 2a squared plus 5a minus 3. Yeah, so that looks familiar to you, right? It's something like you have done before, and you can just factorize it, right, to get a equals to half or a equals to negative 3. Okay, and then, yeah, so this is what we have earlier on, a equals to half or a equals to negative 3. But a is a substituted value for cosine square x. Remember that? Right, and yes, and to find cosine x, you need to square root negative 3, which is inadmissible, so we reject the answer. So we can only work out when a is half. That means cosine square x equals to half. So cosine x will be plus minus square root half. Okay, and remember to find alpha, we only take the positive value. So the positive value is square root half. So it's actually a value for a special angle. It's a value for a special angle, cosine 45 degrees. Okay. Yes, and because it's plus minus means the answer can come from all the 4 possible quadrants. So first answer will be 45 degrees itself. Second will be 180 minus 45. Third will be 180 plus 45. Fourth will be 360 minus 45. So these are all the answers needed. Right, question 13 is tricky. Why is it tricky? It's tricky because if you're not familiar with the trigo identities, if you do not understand how the trigo identities comes about, do not understand how to apply it properly, then it's very likely that you're going to make mistake here. So what is the mistake that you'll be making? The mistake you'll be making is you will think that sine theta plus cos theta is equals to 1. Okay, your trigo identity is sine squared theta plus cos squared theta equals to 1, right? But if you look at the questions that you're given, right, there's no square there. It's just 1 plus sine. It's just sine x only. It's not sine squared. It's just cos x only. It's not cos squared. Okay, and then if you do not understand this identity correctly, you can only use identity when you have sine squared. There must be a square there, and then there must be a square for the cos, right? And if you just go and invent your own one as you sine take it as sine theta plus cos theta equals to 1, then that's it. Okay, then all the whole concept, the whole questions will be marked wrong because your concept is basically just is wrong. So I need to emphasize again that sine theta plus cos theta is not equals to 1. Okay, so then how do we go about solving these questions then? So we need to kind of force it out because we need to force out a square there so that we can actually use the identity. So that's the explanation there. It's going to be very long, but it's basically just, yeah, what I've explained. Okay, recall that sine squared theta plus cos squared theta equals to 1. And since the questions given is not in terms of something squared, we need to square both sides. Is what I mean by force it out before we use the identity correctly. So that's square both sides for the given questions. Okay, that's what you mean by square both sides. Right, so you will have 1 plus 2 sine x plus sine square x on the left. And on the right will be square root 3 times square root 3 gives you 3. Cos times cos gives you cos square x. So now can you see that now, okay, it's legitimate now that you can use your identity. You can just replace cos square x with 1 minus sine square x. Okay, yeah. So this is something that I want you to think about. You can actually express it in terms of sine and cos, but why is it that express it in terms of sine is better? Okay, so you think about it yourself. Okay, so we're going to express cos square x in terms of sine square x. So that will be 3 bracket 1 minus sine square x. And then you simplify it, you end up getting a quadratic equations in terms of sine square x, in terms of sine x. Then you can factorize it. Simplify it further before you factorize it. Alright, so you have two answers. Okay, sine x equals to half. So the possible answer will be from the first and the second quadrant. For sine ratio to be positive, under your ASTC will be first and second. For the positive angle, okay, positive angle, we're dealing with positive angle here. And then you can find your reference angle, which is sine inverse half 30 degrees. It's actually half is actually a special value for a special angle. And so for the first quadrant, it just be 30. Second quadrant be 180 minus 30. Okay, right. And then for the other one, sine x plus 1 equals to 0. So sine x will be negative 1. And negative 1 means the answer must come from the third and the fourth, right? If you refer to ASTC for the positive angle range, right? And if you were to remember your sine curve, right, to get negative 1 is when your x is 270. So you actually don't even need to go and find your reference angle and things like that. Like just try to remember the shape of the curve and its special value. Like sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is negative 1, sine 360 is 0. Okay, so of course this answer will be rejected because it's outside the range given. The range must be given between 0 and 180. So 270 is outside the range. Okay, but not all the answers. Okay, remember when we square something, right? When we square something, we're actually forcing things to happen. So some of the answers may not be legitimate, means that you may not satisfy the original equation. So what we need to do is we need to substitute both values we found earlier on, x equals to 30 and x equals to 150, into your original equations and see whether it satisfied it or not. So let's do it now. Yes, so all the explanations are there. Okay, so we'll do it in the next slide. Right, so how do we do it? So we just basically need to substitute when x is 30 into your original equations. The original equations given is 1 plus sine x, right? So we find the values for 1 plus sine x. So 1 plus sine 30, that gives you 1.5. And then we try to find the values for the right-hand side, which is square root 3 times cos x. So square root 3 times cos 30, you just use a calculator to evaluate, you get 3 over 2. So both answer tally, right? So if both answer tally means x equals to 30 is one possible answer. Okay, let's do it for the next one when x is 150. All right, so you find the left hand side again and you find the right hand side, but the right hand side actually give you a negative. So 3 over 2 of course is not equals to negative 3 over 2, so therefore x equals to 150 is not accepted, is rejected. Okay, so that's how you find out if the answers that you have got in the end whether satisfy the original equation or not. You don't really have to do for all the trigonometric equations. You only do it this time because what we have done is something that is we actually square, you see, something that you are forcing something to happen. So when you force something to happen, there will be some answers that may not satisfy the original equations. Okay, right. So for part 2, explain what happened if you want your angle to be from your second quadrant between 90 to 180 is second quadrant, right? Right, so if you look at the answer from part I, the only possible answer is x equals to 30. So there's no answer from here at all. No answer at all. Okay? Okay, so this one is, they just want to test you whether you know what's going on. Because some people will be a bit like blah blah and say, oh, between x between 90 and 180, for sine to be positive, yeah, second quadrant also can, so the answer is 150. But we have already done in your part I, we already shown that x equals 150 does not work, does not satisfy the equation. You see, so this one is just to test whether you are actually know what's going on or not lah. Okay, right. So that's all for this exercise 11.2.